Hi, special right triangles. Welcome. We're going to be talking about special right triangles. You may have seen it in geometry, but we have to redo it just a little bit so you remember, and then how it relates to the 6 trig functions. Okay, so looking at these two right triangles, these are the special, super special right triangles that we like to deal with, or we deal with a lot in trig. The first one is the 45, 45, 90. So the first one, if you see here, I only put 145 here, but you know this is 45, that's 90, so then if all the angles of a triangle add up to 180, it has to be 45 there. The sides are in the ratio 1, 1, radical 2. When we talk about in the ratio, remember it's always the side opposite. So the side opposite the 45 goes with the 1, and remember we put the x on it, and if you remember doing that in geometry, putting the x on all of those and able to find, if you're given one side, find the rest. So this is the one that would be 1x, this would be 1x, and this would be the radical 2x or x radical 2, depending on how you like to write it. The other one is the 30, 60, 90. So with the 30, 60, 90 right triangle, the 1x and the radical 3x and the 2x, the 1x is opposite the 30 side, so smallest, smallest. They go together, so this is the 1x. 60, so this angle right here is 60 for the same reason. All the angles of a triangle add up to 180. So this one, the side opposite that is radical 3x, and the side opposite the 90-degree angle is the 2x. So from there, we can use that idea to find sides. So given one side, you should be able to find all 3. So this is a 45. It says 45 here, so we know so is this. Okay, so one side is 4. So we know that if we look at our ratio, 1x, 1x, radical 2x. If we want to find all 3 sides, we know that the side opposite the 45, that one we can say, is 4. So x is 4. So knowing that, I simply plug, 1 times 4 is 4, and radical 2 times 4 is 4 radical 2. Okay, I simply plugged x in right there. That's all I did. We just don't normally write the x on, the whole number on this side of the radical. We usually write it on that side. But just was keeping with the whole geometry thing. Okay, so for this one here, this has a 30-degree angle, so you know this one is 60. So we're dealing with the 30, 60, 90 right triangle. And so those are the sides opposite each of those. So 30 is the smallest angle. This was the smallest side. So 1x equals 5. So x is 5. Following the same procedure, we just plug 5 in for x here. And we get 5 radical 3. Oh, wrong spot. Excuse me. Across from the 60. And now across from the biggest angle, that's 10. Awesome? Awesome. That's a 5. My crazy little world. All right, and then we can get more complicated and things get crazy. Not crazy, but more interesting, I guess is the word. And if we want to find all the sides of this triangle, this is 30, so we know this is 60. So this is the side opposite the 60. So remember it's 1x, radical 3x, and 2x is the ratio for 30, 60, 90. This one is this is the 60. So it's 18. This is the side, 18 is the side opposite the 60, so it's radical 3x. So divide by radical 3. Okay, and we get this. Now this is somewhat ugly. We do like to make it look a little nicer, so remember, we rationalize our denominator, and we wound up getting 18 radical 3 over 3, because remember the square root of 3 times the square root of 3 is the square root of 9, which is 3. So divide these in here, and I get 6 radical 3 for x. So if I get 6 radical 3 for x, then I can plug it into this one. 1 times 6 radical 3 is equal to the side opposite the 60. So that's just 6 radical 3. I mean the 30. I'm awesome. So remember, this one is the side opposite the 30 degrees, 60 degrees, and then 90 degrees. So then we have to figure out this one. So it's 2 times 6 radical 3. Remember, outsides only get multiplied together, and the radical 3 comes along for the ride. So it's 12 radical 3. All right, so that's it. Many different ways, things that you're going to see, but that's the basic idea. How am I going to use this in trig? Well, one of the major ways we use it is we really care about the degrees, or this, what the sine of 30 degrees is, what the sine of 60, and 45. So those are important ones to us. In this particular one, we're looking at the 60 and the 30, and all 3 of them. So looking at this triangle, just because it's nearby, it's a good one to look at. Based on number 2, this is number 2, what is the sine of 30? So this is 30. This is the side opposite. So the sine is 5 opposite over hypotenuse, or 1/2. Okay, what is the cosine of, I'll move over to the side here. What is the cosine of 30? Same basic idea, but it's adjacent. Adjacent is 5 over 3. Hypotenuse is 10. We reduce this, radical 3 over 2. So no matter what you do, the cosine of 30 will always be radical 3 over 2. That's what we call an exact value. Okay. So how about the sine of 60? So 60 is over here now, so we're using this angle. Sine of 60, opposite over hypotenuse. So the opposite is 5 radical 3. The hypotenuse is 10, radical 3 over 2. Now this is an interesting concept. They're both radical 3 over 2. But it's a cool thing. Okay, cosine of 60 is adjacent over hypotenuse. Awesome. Okay, tangent of 60. The tangent of 60, remember this is your 60 here. So opposite is 5 radical 3. Adjacent is 5. So tangent of 60 is just radical 3. Those cancel themselves out. Tangent of 30, opposite over adjacent. So it's 1 over radical 3. We rationalize, so it's radical 3 over 3. So those are some major values that you have to remember. Doing the same thing with 45, if this guy is 10, okay, we remember our ratio is 1x, 1x, radical 2x. This is the biggest side, so is that. I mean, this is the biggest side, yeah, so is that. Radical 2x equals 10, divide by radical 2, and we get 10 over radical 2. We want to rationalize, so it's 10 radical 2 over 2, and so it becomes 5 radical 2. So that's what x is. X is 5 radical 2. So we just plug it in here, so it's 5 radical 2 for each of these guys. Using this information, what is the sine of 45? The sine of 45 is opposite over hypotenuse. So reducing this, radical 2 over 2. Okay, do that for the rest of them. And this one is radical 2 over 2. And this one is 5 radical 2 over 5 radical 2, which is 1. Okay, using this information, fill in this chart. I'm going to put the answers up quickly. All right, here are the answers. You need to be able to fill in this chart on your own. Couple hints for memorization. 1, 2, 3. 3, 2, 1. And they all have 2 in the bottom. So it's just an idea to remember. But now that you know the special right triangles, you may just want to use the special right triangles. You know those ratios and just take it from there. It's up to you. let us go. All right, exact values. So what we've done in the past, or the couple days ago, is we talked about equivalent values, and that's really what we're going to be using here. Now, I don't know exactly what the sine of 240 is, but if I find the reference angle, then I might be able to find the exact value using the reference angle and this information, or the special right triangles. So I'm going to show both ways to kind of go about this, and hopefully it will make sense and not confuse you. So when I say exact values, I mean don't round. Don't round. Okay, that means leave the radical, leave the fraction. Don't put it in your calculator. You have to leave it. Alrighty. So the sine of 240, we're going to do our equivalent value thing, which is the way I taught it was the box, line, box. Okay, 240 is in what quadrant? It's over here somewhere. So it's in quadrant 3. So sine is negative. Okay, find the reference angle. So I want to go back to 240. From 240 to 180, I want to cut out 180 degrees. So subtract 180 from 240, and I get my 60. Okay, so sine of 240 is the same as negative sine of 60. Now, if you look up at your chart, you know the sine of 60 is radical 3 over 2, so it's negative radical 3 over 2. That's it. That's all you have to do. So try for cosine and tangent, and then we'll do secant, cosecant, and cotangent. All right, so here are the answers to this one. Number 2, Number 2, radical 3 over 2, positive radical 3, and number 3, positive radical 3 over 3. Okay, so we'll practice this more in class, but we're going to do a little bit with secant, cosecant, and cotangent because we don't have to memorize those, but you may find it useful. Now, there's a couple ways to do this. All right, for this one, for secant, I'm going to show you, if you find out what the value is, this would be the secant of 135 when we convert. Okay, remember when you're converting, it's multiplying times 180 over pi. Yeah, that's right this time. Okay, so secant of 135. So 135 is over here. Secant, just as a reminder, is the reciprocal of cosine. It's 1 over the cosine of the angle. So it's negative, so cosine is negative here. So this is negative the secant of 135. The reference angle of 135, how many degrees? To get to 180, that's 45. So the secant of 45, there's a couple ways to think about it. You can think about it as 1 over the cosine, or negative cosine of 45. But when you're doing that, you're kind of dealing with a lot of radicals. So you get 1 over negative radical 2 over 2, then you have to flip it. It's kind of a lot of work. It's the way I do it, but now that we're using the right triangles and the special right triangles, it might be easier for you to simply look at your special right triangle. So we'll draw this over here. So if I draw the 45, 45, 90 right triangle, remember it's 1, 1 radical 2 ratio. Remember 45 is one of these angles. The secant, if you remember, is negative the hypotenuse over the adjacent, right? So the hypotenuse is radical 2, and the adjacent is 1. So this is simply negative radical 2. And that may be the easier route to take than flipping radical 2 over 2, because you memorize that and then doing it. It's up to you. You'll decide when you do your practice tomorrow. So I'm going to do that a few times here and see how that goes. So this one, 225, remember, cosecant is reciprocal of sine. So since this is ASTC, this is going to be negative the cosecant of 45. Our reference angle is 45 again. So same basic idea. We're looking at this right triangle right here. The cosecant is the hypotenuse. I'm going to write a different color. The hypotenuse, which is radical 2. We'll do the negative because this is negative here. over the opposite. So it's simply negative radical 2. Awesome. And then finally, the cotangent of negative 5 radical 3. Try that one out if you want. Pause it, whatever. But this is the same as cotangent of negative 300. So negative 300 takes you all the way up here to quadrant 1. Okay. So in quadrant 1, cotangent is positive, so is everything else. So it's positive, the cotangent and the reference angle of 300. I need to get to 360, so it's just 60. Remember, the reference angles are always positive and acute. And then we just do the same thing. The reference angle is 60. So if I look at my 60, like you could do this as 1 over the tangent of 60. Absolutely acceptable. Might have some rationalizing to do there. So if I make this, no, that's not 60. If I make this 30, this 60, remember it's 1 radical 3, 2, and so the cotangent of 60, cotangent is adjacent. Remember, this is your 60, so cotangent is adjacent over opposite. So you should rationalize. So it's radical 3 over 3. All right. Have a great day. I hope you know what you're doing. Bye.